Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video, we'll do a homework problem from section 10.3. It says that the data shows systolic and diastolic blood pressure for certain people. They want us to find the regression equation, letting the systolic reading be the independent variable x. They want us to find the predicted diastolic pressure for a person with a systolic reading of 125. And they ask if is the predicted value close to 99.6, which is the actual diastolic reading. Okay, let us use StCr for this, and let's open it up at StCr. And here's our data. We will go to stat and regression, simple linear. We'll select the x variable, systolic, the y variable, the diastolic. And we don't need to do a hypothesis test for this problem. We don't need a confidence interval either, but let's just select that one. And the best predicted value for 125. There's a bunch of other things. Let's just do a graph just for the sake of looking at it, eyeballing the correlation, and I think that's it. We have our results rather quickly. Just a quick look at the graph. It looks like there's some points. There's a lot of points and they're kind of far away from the line. I would guess there could be correlation, but most likely not. And we can take a look at the p-value to confirm. Well, it looks like it would be close if you had a 0.10 significance level, but we're looking at a 0.05, and so this is bigger. And if it's bigger than that, well, we're not able to reject the no correlation null hypothesis. So I would say no correlation for this, which will be an important factor for us in making our decision and finding the prediction. But for now, let's take a look at the line. The regression line has a y-intercept of -26 and a slope of 0.85. So let's get the first one going, our y-intercept. And they want us around to 2 decimal places, so it's just going to be -26.01. And then our y-intercept, let's get our y-intercept down here to 2 decimal places. It's going to be 0.85. Alright, the prediction. So if this had correlation, our predicted value would already be computed for us. It'll be 80.379. And let's just put that in our answer. It's not going to be correct, round off to 1 decimal places, or 1 decimal place. It's not going to be correct because we saw that there was no correlation. So if we hit enter here, we'll say that check to see if there is correlation. If there is correlation, use the regression equation to make the prediction. Otherwise, they want us to use the mean of the y values. So this is not correct. Let's fix it. And we want to find the mean of the y values. So let's hide this for now. And here are the y values in the diastolic. Let's go to stat and do a quick summary stats on the column. And we just want the diastolic column. We want to find the mean. We can also find the standard error and all that stuff, but let's find the standard deviation. Let's find the mean and standard deviation for this. And here's our summary statistic. So the mean is going to be 86.125. Round off to 1 decimal place, so that's just 86.1. Okay, Now they want us to answer this question. Is a predicted value very close, not close, exactly the same? It's not exactly the same. Is it close? So the difference is 99.16 and 86.1. So the difference is about 14-ish. So I think the standard deviation would play an important part of this. Standard deviation is about 17, and the difference is about 14, 15. So it's less, but it's not that much less. And so it's actually, I think, fairly close means about half of a standard deviation away or something like that, but I don't think this was close at all. So let's select this, not close. Alright, I hope that helps.